Good morning, everyone. How did your homework go? Okay, any questions from the homework? Please get going. Okay. All right, so I repeat the last thing we did yesterday, and if you have any questions, we cover them. So the last thing we did yesterday, I would like to repeat it because I did at the end of the hour, was the acceleration. Okay, so the word acceleration actually means, so if you're accelerating, what you're actually changing is your velocity. So let me ask you a question. Let us say you drive for an hour at a constant velocity of, let us say, 90 miles per hour. So you are somewhere in Montana, there is nobody there, and you can drive as fast as you want. So 90 miles per hour for a 1 hour period. What do you think is your acceleration? So you drive for 1 hour, 1 whole hour, 90 miles per hour. So there is nothing. I mean, nobody's stopping you and you can keep moving. Your acceleration is absolutely zero because the acceleration has nothing to do with how fast you're going. The acceleration has to do with how fast is your velocity is changing. So it's measure of the change in velocity has nothing to do with the distance. Okay? So based on this idea, so acceleration measures how fast the velocity is changing. The velocity is changing. Okay. So what is basically, since the velocity can change continuously, I mean, you can be driving and you can keep changing your velocity. So the acceleration, if you have S of t, a position function, so object is moving, that's the position. The velocity is how fast it's moving, which is the derivative of the position. This one measures the limit of how fast the distance. So that's the change of, or the displacement, or how much you're moving over how long. So that's intuitively displacement over time. And that's given us the velocity. The acceleration, and usually we use the letter T for it, is velocity over time. So how fast, so it's the change in velocity, how much your velocity changed over how long it took to do this change. And the smaller the time period, the better approximation of how fast the velocity changes, which is nothing more than the definition of the derivative of the velocity. Okay. So we have now the following for a line for an object in motion. Velocity is the derivative of the position, ds dt. Acceleration is how fast the velocity. So it's the derivative of the velocity. And now let us use a little bit Leibniz notation. No, not Leibniz, sorry. The velocity is the derivative of the position. So it means that the acceleration is the second derivative of the position. So that's one of the very important application of the second derivative. It's give us the acceleration. Now in Leibniz notation, how do we write this? It's d squared s dt squared. So d squared s dt squared, which means the derivative with respect to time of the derivative of the position function. Okay, so these are the notation. And finally, the unit of the acceleration. Okay, and really depends on the unit of everything else. So let us say S measured in feet, time in second. So the acceleration, the unit is intuitively, it's the change of velocity per change of time. So it should be feet per second, that's unit of the velocity per second. How much the velocity changed per second. That's really what it measured. And we use, as I'm sure a lot of you know, feet per second square. But what it means is feet per second. How much the velocity change per second. That's really what the acceleration really represents. Velocity per second. And we use this as a notation for that. So this reflects this idea. Okay. So that was a quick review. I will do one of the problems and then I proceed if you guys don't have any question whatsoever. The only thing, again, I forgot to mention yesterday is about the speed. The speed is the absolute value of the velocity, okay? Because the velocity could be positive because the velocity is displacement over time. And the displacement can be positive or negative. So the velocity is usually positive if the object moves in the positive direction, whatever direction we choose to be positive. Object move in the positive direction. And it's negative because it's displacement. The displacement can be negative. This negative object moves in the negative direction. Okay, so that was a summary of what we did yesterday. So I will do one problems and then we will move on to the following section. Okay, any questions, please, as I go on. Don't be too quiet. Okay, so I will look at one of the problems I assigned. I pick one of them. So let me put number, let us say 15. I think I assigned it. I usually will. Okay, so we have the position function s of t. And the one in the book is t squared minus 4t. And they give us a limit on time. So they tell us the time is between 0 and 5 as the time. All right, and then they ask us several questions about that. So the first question is graph the position function. Okay. Now, this is a simple parabola, so I'm going to graph it. That's a simple parabola. And it's parabola going upward because it's positive t squared. And if t equal to 0, I am at 0, and this is going up. And I mean, I know that you guys use calculator, but sometimes we don't need to. And I like to find its zeros. Now, if I want to find when it hits this, the t-axis. So I factor this out, equal to 0. So it means at 4, it's at 0, so it's going to go down like this and go up. At 5, we are somewhere here because they restrict our time limit. So that's really my graph. Now, the second question is find and graph the velocity. So let us find the velocity. So this is s of t. It's t squared minus 4t. So b is the velocity. So let us see what's the velocity. The velocity is nothing more than the derivative of that. So it's 2t minus 4. Okay, so that's absolute derivative. Now they want us to sketch the velocity. And actually we can sketch it in 2 ways. And either we sketch this or we remember how we sketch the graph of the derivative. Regardless how we do it, we're going to get exactly the same. So let me sketch this graph and then make sure that we're actually getting the graph of the derivative. So s of t is nothing more than a line. That's a line. And the intercept is at minus 4. And this line is going upward because the slope is positive. So it's going to go like this. That's how it will go. But the question is, what's this point right here? This point right here basically corresponds to when the velocity is 0. That's what we mean stationary. Stationary is when the velocity is 0. So if I want to find this point, so the question when velocity is stationary, when the point is stationary, it means when the velocity is 0. So if the velocity equal to 0, when 2t minus 4, 0, t equal to 2. So the velocity is 0 here, and this is nothing surprising. The velocity is 0 right at this point. So when I'm graphing, whether I graph this line or I graph the derivative, we have to get exactly the same. Okay, so let us verify that. Derivative is negative, negative, negative. The velocity is negative. The derivative start becoming positive, the velocity is positive. So whether you draw this line, you go from here to here, exactly the same. And this is 2, because that's exactly when the derivative is 0. Now, when is the object moving to the right and when is the object moving to the left? So let us say going this way, that's positive direction. This is my reference point. Why is it going to the right? Okay, let's watch the graph. We're going to do it 2 ways. If I go from here, I look at the position. The object was at 0. And then as is becoming negative, means the object is actually moving away. So it's negative, away from, so it's going to the left from the reference point. At t equal to 2, it's heading toward the reference point. At t equal to 2, it's heading toward the reference point, and then it's going this way. So up to 2. So that's t equal to 2. The object is here. So object going to the left from 0 to 2, and from 2 to 5, it's going to the right. Now the velocity tells me the same thing. When the object is going to the opposite direction of the motion, the velocity is negative. So right here, we're moving to the left, which reflects this picture. When the velocity, because the displacement here is going to be negative, when the velocity is positive, we're moving to the right, which reflects this piece right here in S of t. Okay. All right. So moving to the left between 0 and 2, and after that, moving to the right. Now a little bit more question. Find the velocity and the acceleration. Okay, so now they want us to find the acceleration. The velocity is 2t minus 4. So they want the velocity at 1. I plug in 1 into here, so I will get 2 times 1 minus 4, which is minus 2 feet per second. Means after 1 second of the object moving, I mean, we know that the object, this velocity is negative because the displacement here is negative, the object going to the left. And how fast is moving? Minus 2 feet per second. The acceleration is the derivative of the velocity. The acceleration is the derivative of the velocity. And in this case, the acceleration is equal to 2. So it's a constant number. So whether it's 1 or 4, the acceleration is always equal to 2. So the acceleration is constant. And actually, if we graph the acceleration, this is a straight line. The derivative is going to be nothing more than a straight line as well. Now, D, determine the acceleration when the velocity is 0. So they want me to find A of t when the velocity is 0. All right. The velocity is actually, in this problem, the acceleration is always constant. So whether the velocity is 0 or not 0 is actually, it doesn't really matter. But let us say the acceleration, you have a different problem where the acceleration is negative. The way you have to do it is, first you find when v of t equal to 0, and we know that this is t equal to 2. And then the acceleration at 2 is in this problem exactly 2. And finally, when is the speed increasing? When is the speed increasing? What's your answer? When is the velocity increasing? So I'll go back to the picture. And the question is when the speed is increasing. The speed, remember, is the velocity, but in absolute value. It means your actual, how fast you're moving, not the velocity here, minus 2 feet per second after 1 second. The minus tells me that we're moving to the left The 2 tell me exactly how fast you're moving. So this tells me the speed. So the speed is 2, but the speed doesn't tell me the direction. The minus tells me the direction of motion. That's really what's happening. So now back to you. When is the speed increasing? Who would like to answer? You guys are too quiet for me today. Between 2 and 5, Luke is correct. Why between 2 and 5? So the speed is increasing here. Okay. If we graph it, how is the speed? The speed is the absolute value of the velocity. If this is the graph of the velocity, what is the graph of the speed actually? The speed is the absolute value. It means wherever the velocity is negative, so I'm going to sketch the speed in red. The velocity is negative, the speed is positive. The same value, but it's positive. The velocity is negative, it's the same value, but it's positive. The velocity is negative, the same value is positive. So the red here is the graph of the speed. That's the graph of the speed. Okay, because the speed is nothing more than the absolute value. And now I look at this graph. One is the speed increasing. It means one is in this graph, one is the speed increasing. It's increasing for t between 2 and 5. Yes, in this pattern. Okay. All right, so that's like a review of what we did yesterday. So I know some of you, I mean, quite a bit of you haven't done your homework. Please do your homework. All right, any question before I move on? There we go. So today we're going to move to section 3.6. One of the basically main rule of differentiation, not the main rule, it's like basically the last rule in a way. After that, it's more formulas. So section 3.7, the chain rule. So we've seen so far the following. We've seen if like how to find the derivative of like x squared, e to the x, and sine. And then we saw how to find, if we add them, what to deal with the sum of them. So derivative of the first plus the derivative of the second. And then if we multiply them, we learned how to do with that. We use the product rule. And if we divide them, again, we learned how to do with this. So we learned how to do with each one of those operations. Today, our goal is to find the derivative of something like that. So the goal is basically to compose them, because we know that we have talked about composition of function. So the goal now is to find how we find the derivative of the composition. So let us see a problem where composition is natural. So the goal is to find the derivative of the composition. But first, let us see a situation where the composition is absolutely natural of the composition. Okay, so suppose I give you a function y, and this function is, let us say, the square root of 4 plus x squared. That's really my function. Now, here's the thing. What am I supposed to do with the square root of something? I know how to handle this piece, but now I have the square root of that. It doesn't fit in any of the scenario. It's not a product. It's not a quotient. It's not the sum. It's the square root of a sum. It's absolutely the square root of a sum. So this, we're going to look at this as a composition of two functions. So let's remember, if I want to write this as a composition of function, what's going to be the inside and what's going to be the outside? So let us recall that. What is the outside function in here? So I'm going to write as composition. Okay. And so we're going to go back a little bit to the beginning. What's the outside function and what is the inside function? It means I want to write this as, I want to write it as f of g of x. F of g of x. So to be able to write it as f of g of x, what is my outside function? What's the last operation I do? So it's the square root of x. Now what's the inside function? Nick? The 4 plus x squared. We're going to call it g of x. That's the inside function. So that's the squaring root is the outside, and the inside is 4 plus x squared. So that's something we did at the beginning. And this is this type of function that we're going to talk about how to differentiate it. Now, to be faithful to the book, actually, sometimes instead of writing f of x is square root of x, we're going to introduce a variable u. So we introduce, nothing is changing. We introduce a variable u. And we're going to rewrite this in the following way. Rewrite it. Okay, we're going to set u to be, so the inside, I'm going to set it to be equal to a u. So u is the inside function. Okay, and the outside, instead of writing it as a function of x, because I want to reflect this, I'm going to write f of u to be the square root of u. So a little bit change of the variable, no more, no less. But let us check that it doesn't really matter. Even if I put f of u equals square root of u, instead of putting of square root of x, really nothing changed, because a function is not determined by the name you give to the input. It's determined by what it does. So those two do the same thing. They square the inside. They take the square root of the inside. That's really what about it. So we're going to introduce u, and we're going to write the square root of 4 plus x squared. So now if I use this notation and I find f of g of x, it's really going to be the same, because forget about this. G of x is 4 plus x squared. What f does is taking the square root. Whether I call this x or u, it doesn't really matter. So this is the function I'm really interested in. That's really the function that I'm interested in, how to find the derivative. And the chain rule is a rule that we're going to state, which is going to actually solve this problem. So what does the chain rule tells me? Tells me the following. If I have the composition of two functions, so I have f outside of g of x, that's what I'm interested in, then the derivative is a product of two derivatives. It's the derivative of f, which is the outside, but at g of x. So derivative of the outside evaluated at the inside times. So it's a product of two different derivatives times the derivative of the inside function. Okay, so again in word. Derivative of the outside, so it's the derivative of outside evaluated. It means we find the derivative of the outside and we find its value at the inside function. Times, you multiply it by, so you times this by derivative of the inside. So this is basically how we read it. So if you have the composition, the derivative is, you take the outside, you find this the derivative at the inside function. You multiply this by the derivative of the inside. Okay? So there are two different ways of writing the chain rule. I will use this one today fully, and tomorrow I will introduce the other way of writing the chain rule that use the dx notation. But today I will only work with this one. Okay, so let us get going. Let us start applying this formula on a lot of problems. So I will start. So I'm going to take it and keep it right here in front of me. Every time I pick a new page, I will try to have it in front of us. So the derivative of f of g is the derivative of f of the outside at the inside times the derivative of the inside. Okay, I'll always refer to it. So, example. Let's go back to the problem I started with. So find the derivative of the following function. So first example is y equal the square root of 4 plus x squared. Okay, so the idea here is we have, this is a composition, so we're going to use the chain rule. Okay, verbatim. So the first step is to write it as a composition. So we have to pick our outside and the inside, only two. The outside is the last thing we do. So instead of using f of x, I'm going to use u for the outside. So the outside is f of u is the squaring function. The inside is g of x is 4 plus x squared. Right? Now, what does this formula tells me? Okay, so what is y prime? What's the derivative? It's the derivative of the outside evaluated at the inside times, so that's multiplication, the derivative of the inside. Okay, so before I do this, I'm going to find what's the derivative of the outside. What's the derivative of the outside? The outside is the square root. What's the derivative of the square root? Now, square root, to find its derivative, I have to rewrite it. So the derivative of the outside is the derivative of the square root of u, which is a half u to the half minus 1. It means a half u to the minus a half. That's the derivative of u. G prime, nothing. G prime, I don't even have to write it here. I usually don't. Is 2x. Now, what is here? This is equal to what? The derivative of the outside at the inside times the derivative of g. Now, usually I like to write the derivative of g again here because it's easier. What is f prime at g of x? What does f prime do? F prime of u is a half u to the minus 3 half. So at g of x, what's the f prime at g of x? I plug in g of x for u in here. So it's going to be a half. Instead of a u, it's g of x, which is 4 plus x squared. And that's really times the derivative of g. So this will be a half minus 3 half. Oh, sorry. Where am I getting this minus 3 half from? You guys correct me if I'm doing something stupid. Okay. Okay. 4 plus x squared to the minus 3 half. The derivative of this is equal to 2x. So finally, the 2 and the 2 simplify, and I can write this as x over minus 3 half will become the square root of 4 plus x squared. Okay, so let us repeat the process, and we're going to work on this the whole hour today. Okay, so let's repeat the process. So I have here a function that none of the rule I've learned so far actually apply. So this is a composition of the functions. So the first step we're going to do is to pick the outside and the inside. The outside is the last operation you do when you're computing something like this. So if you're computing the square root of 4 plus x squared, you compute 4 plus x squared, and then you take the square root. So the square root operation is the last operation. So you pick the last operation you do, which is the square root of u. And then the leftover, which is the inside, will be 4 plus x squared. Okay. Now, the formula tells me that you have to find the derivative of the outside. So I go ahead and find it. The derivative of the outside is a half u to the minus a half. But then you have to evaluate it at the inside. So once I find it, instead of putting q, I have to put the inside. So it becomes 4 plus x squared to the minus a half times the derivative of the inside, which isn't a big deal because the inside is a simple function, which is 4 plus x squared. Once I do that, I start verbatim applying. Once I do that, I'm basically done. I just do some simplification and end up with my example. All right. So I'm going to take lots of examples. Some of them I want you to do in front of you, and then we see whether you got it right or wrong. So I'll take another page. Where did you get the square root in the denominator? Okay. All right, let me take back. If you have any number, forget about that. A to the minus a half. All right, because the power here was a minus. All right, a to the minus a half is what? It's 1 over, because I have a minus here, a to the power a half. All right, it means 1 over the square root of a. That's what we get. So in this problem, I had 4 plus x squared to the minus a half, which is 1 over 4 plus x squared to the power a half, which is 1 over the square root of 4 plus x squared. Okay, thank you very much. Please ask questions, because I proceed otherwise. Nice. All right. So now let's take another problem along the same line. It's going to be all along the same line. So let me find again the derivative of the following function. Suppose I take y to be, so this one's going to be easy. I mean, not easy, but verbatim application. 1 plus x squared. I don't know why I'm putting x squared all the time. So let me put e to the x, okay, plus x squared to power 10. So just some kind of a drilling problems. So again, nothing that I've learned will help. I mean, I can multiply this by itself 10 times, which is a nightmare in the making. So we're not going to do that. So I need to find the derivative of this function. So find the derivative. Okay. And I want to apply the chain rule. I don't have other tools but that. All right. So we're going to use the chain rule. So to do it, we first have to start choosing our inside and the outside. So what is my outside function? And what's my inside function? All right. So let's get back to you. I can call f of u, that's my outside, and my inside, which is the g of x, equal. All right. Quickly, what is the outside function here? I'm listening. I mean, I'm reading, I'm listening. You do whatever you want. Let me know. X to the 10. So, but I'm going to use u to the 10, Elizabeth. Okay, just I'm going to only change, right? I'm going to only change, instead of writing x to the 10, u to the 10, which is basically the same thing. Because as I said, the name of the variable is not the one that matters. Is what the function does is really what matters. It takes an input to the power 10. My inside is now e to the x plus x squared. Okay, so now I'm going to find y prime. All right, what is y prime? Okay, the rule. It's f prime at g times g prime. Okay, I keep saying it because I want to really to become very, I want you to internalize it. Derivative of the outside evaluated at the inside times the derivative of the inside. Now I need to find each one of them. So what's the derivative of the outside? I go back here and I find it. What is f prime of u? What's the derivative of that? Here, I'm thinking of u as my variable. It's 10 u to the 9. Okay, g prime, I don't actually even need it because I can figure it out very quickly. So it's going to be equal to g prime is the derivative of the inside. So I like to keep it like this here and compute by itself. Okay, now f prime at g, it's what? It's 10 times, and this is what you have to be very careful. I have to evaluate this at g, so e to the x plus x squared to the power 10. And now I'm done. So this is going to be equal. Now, Ali, I read your message, but I can't really say anything because, so your classmates are answering you. Times, derivative of that is e to the x plus 2x. And there is no simplification that I can really do at this stage, okay? All right, so now I'm going to start giving you two problems, and I expect to see answers from you guys, but I want you to do this step. Actually, I want you to do those steps for now because are crucial. Later on, of course, nobody is going to do those steps, but for now, I want you to show all the work. And when I quiz you on Friday, your quiz will totally require from you to show me all the work, or I will not accept the answers. All right, so let's take another one. Now I'm going to take y to be cosine of, I'm going to try an easy one, cosine 3x. First, let us get one thing straight, one thing very clear. One thing. Cosine of 3x is not 3 cosine x. In other words, you cannot take the 3 and put it outside. Absolutely wrong. Take any value of x, you realize that this is really failing for us. Okay, so we cannot put the x outside. So this piece is totally inside. Now I give you 3 minutes for you to give me the answers. And I want you to do it actually the way I've been setting it up. Find your inside, find your outside, write this, and then find the derivative. You have 2 minutes to do it, get going. Okay, Nick, minus this. Okay, Nick, what's the outside? F of u equal to what? Yeah, cosine. Okay, what's your inside? Quick, Nick, answer me quickly. 3x, very good. So now what's the derivative? F prime at g times g prime. So it's equal to, all right? So to do that, I have to go back. What's f prime? So I go back here. What's f prime of u? It's minus the sine of u. So this is going to become minus, it's f prime. The f prime is the derivative of the outside. So the outside is cosine, f prime is the derivative of the cosine, which is minus sine, but we evaluate it at the inside. It means we evaluate it at 3x. That's this part. And then we multiply it, so that's the product of derivative, by the derivative of the inside, which is 3. And finally, I will get minus 3 sine x times 3. Or if you want, minus 3 sine 3x. End of the problem. Okay. All right. Let's move on. Let's keep working on the same type of problems because chain rule is absolutely crucial. Okay, so here it is. Okay, I'm going to move on. If you guys, I hope you guys are done. Okay. So now let me take the following function. Again, I'm going to ask you to find the derivative. So y equal sine cube x. Okay. And the question is, we need to find the derivative of this function. First, let us remember something important. What does sine cube x means? As I said before, that's a notation, and we cannot work with it easily. So whenever I have sine cube, I rewrite it so that I make sense out of it. What does sine cube x mean? This has to be exactly my first step. It's sine of x to the power 3. Unless you write it this way, you cannot make sense out of this expression. So sine cube x is the sine of x raised to the power 3. Now I want you to go ahead, once we rewrite it this way, which is a crucial step, now we are able to find its derivative. Again, you guys have 3 minutes to do it. So I want you to introduce the inside, I want you to introduce the outside, and then I want you to write it as this, derivative of the outside times g prime. And then find the derivative. Okay. Nick, you're right. I want somebody else. Those who don't know it. Let us start. What's your outside? Now, once you write it this way, figuring out the outside and the inside is not hard anymore. So what is the outside? And what is the inside? So we're going to call U for the inside. That's my G. All right. It's the cubing. That's the outside operation. You cube. The inside is the sine x. And then verbatim. I mean, there is nothing really left at this stage. So I need f prime. Very good. What is f prime? So what is f prime? F prime, so that's u to the power 3. The derivative is always 3 times u to the 3 minus 1. So that's the derivative of the outside. And now I just have to go back here. What's the derivative of that? It's 3 times, sorry, it's 3u squared, so derivative of the outside, but evaluated at the inside. Means instead of u, we're going to put my inside here. Times the derivative of the inside, it means the derivative of the sine. So finally, I would get 3 sine square x times the derivative of sine, which is the cosine of x. Okay. Now let us do, again, as I said, the same line. We're going to keep going. And okay, I would like to do 2 more, at least today. Suppose I give you y to be e, let us say e to the, I don't know, e to the square root of x, why not? Okay. Again, this is nothing we've learned, will work. So I want you to find this derivative. Again, we're going to use a chain rule. And I'll give you 2 minutes to do it, all of you. Okay. I would like to put their answer. I want a variety of student. I don't want only the same student. Who can put the answer that is not sure of it? that's the price of online. So what is the outside function? The outside is, what's the outside? The exponential, right? That's my outside. And what's my inside is the square root. And since we know we're going to differentiate it, and we know the derivative doesn't like square root, we have to put it exactly. So now let us find y prime. So y prime is this derivative of the outside evaluated at the inside times the derivative of the inside. So now let us do that. Okay. The outside is the exponential. And we know that the derivative of the exponential is the exponential itself. So the derivative of the outside is the exponential e raised to the power, so evaluated at the inside, it means to the power g of x times the derivative of g, which is derivative of x to the half. So this will give me e to the square root of x times e to the power a half is a half x to the half minus 1. So now I just collect stuff. So it's going to give me equal to a half e to the square root of x, x to the minus a half. And as we did a minute ago, you can keep it like this, it's okay. Or you can write it, because we should be able to do that. X to the minus a half is 1 over the square root of x. So this would give me 2 over the square root of x. Okay. All right, now we're going to do one last problem, which is, of course, the following. Suppose I give you y equal this. Okay, sine 4 of x squared plus 1. Okay, all right, so that's my last example today. And we need to find the derivative. Can you back to the last problem for a second, please? Absolutely so needy. Okay. So I'll keep this in front. And I will put this one here. So, okay. All right. So y equals this one. And the question is to find its derivative. Okay. The first step, even though whether you do it or not, you have to learn how to do it, is we have to rewrite this in a format we understand. There is no way out. So it has to be rewritten like this. So this one is a little bit more complicated, but it's not a big deal. All right. So what's how we're going to find the derivative of this function? Okay. So this is a chain rule because it's a composition. So what's going to be my inside? Sorry, usually I write the outside first. Outside, inside. And here I would like to make a comment. The outside means the last operation you do. The inside is what's left. That's the way I want you to think of those problems. So what's the last operation you would do when you're evaluating an expression like this? Exactly. That's first. So the outside here, because this problem, there are a lot of scenarios for the inside and the outside. But for the chain rule to work smoothly with you, the outside is the last operation you do. And the last operation is raising to the power 4. So this is my last operation, u to the 4. The inside is, after that, the leftover, if you want. So the inside, that we call the g of x, will be the sine of x squared plus 1. Okay, so that's what we can do. That's about what we can do. So now let us find the derivative of this function. So what is y prime? It's f prime, the derivative of the outside, evaluated at the inside, times the derivative of the inside. So it's equal to, now, what is f prime? Okay, what's the outside? The outside is something raised to the power 4. So the inside is going to be 4u to the power 3. So that's the derivative of operating on the outside. So it's going to be 4, but it's not u because we have to, for us, wherever there is u, we have to put g. So my g is the sine of x squared plus 1, the whole thing to the power 3, multiplied by the derivative of sine x squared plus 1. Okay. Now here's the thing. So this is easy. The first part is easy. So I'm done with the first part. Times. What about this one? Sine of x squared plus 1. How can I find the derivative of that? Is it trivial like before? What are we going to do? If you look at it again, that's another chain rule, right? So this is another chain rule. We have to do another chain rule because this is again a composition of x squared plus 1 and the sine function. So even when we hit, we have to apply the chain rule again. That's why it's called the chain rule, because a lot of times it's a chain. We have to apply it over and over and over. So now to apply this chain rule again, I have to go back to the side, if you want, and find the derivative of sine x squared plus 1. So I will go back to the side, basically, and I isolate this. Eventually you won't do that, and I look at sine of x squared plus 1. I have to find the derivative of that. So again, I'm going to introduce inside and outside. For this one, now the little piece, the outside is the sine. That's the outside. So now I'm concentrating on this little piece. The inside is the x squared plus 1. That's my g of x. So what's going to be the derivative here? So the derivative of the outside in this scenario is the cosine of u. So this is going to be the derivative of the outside, which is the cosine, but you evaluate it at x squared plus 1. So instead of u, you put your inside here, times the derivative of the inside. Never forget that, ever. And now we're basically at the end of the row. We're almost done. Cosine x squared plus 1, derivative of x squared plus 1 is 2x. So finally, I will get 8, 2 times 4, x. So that's to be written nicely. Sine cube x squared plus 1 times cosine of x squared plus 1. And this is in x. Sorry, just to make sure it's not multiplication. That's in x. Okay, so it's a chain rule within a chain rule within a chain rule, and yeah, that's will occur because function can be composed a lot. The main thing is that when you start the process, your outside has to be the last operation. That's how you break it. And then what's left will be your inside. Once you do it this way, then the rest will become kind of repetitive. But that's what the first step is. Focus. Your outside is really the last operation you're going to perform. All right, so I stop here. So please do the home. Some of you are really lagging in doing your MyLab homework. I check on you every day, and I know exactly who did it and who didn't. So please do your MyLab homework. Don't fall too much behind. Okay, so I'm going to assign some problem along those lines for tomorrow. Okay, any questions? Anything before I go? All right. Okay, so as usual, bye for now, and I'll talk to you tomorrow. And I have office hours, as you know. Please drop by.